Hi there, and welcome to this introduction to Captell Capacity Management Capability. This program is aimed at enabling an organisation to get to a capacity management maturity level very quickly. It's designed to extract data out of your existing monitoring systems, loads it into the Captell Capacity Management database, it summarises that data, it trends that data, and then throughout a planning period, it tracks the baseline planned data against the actual values. Configuring CMC is made up of 4 processes: defining views in the database to read the source data, loading that data to the database, defining metrics and devices, defining plans. To get data into the system, we define a view in the CMC database which reads the source data. We use the Source Input tab to tell CMC about that view. To load data, we simply go to the Processing tab and click the Load Data button. As part of the loading process, CMC identifies any metrics in the source data and adds those metrics to the Metrics tab. Here you can define how you want those metrics treated. In this case, we've got a metric called percentage used, which we know is a CPU utilization metric, so we've renamed it. This way all metrics relating to CPU utilization are named the same. We can say we want this metric summarized, we want it trended, and if it's trended, we can specify which summary value is going to be trended. In this case, it's the 95th percentile. In addition to those options, we can specify a comparator and a threshold. So in this case, we want to know when CPU utilization percent is greater than 80%. Once that's saved and the data is summarized and trended, the system will automatically do comparisons with the new values against the thresholds and give you warnings when you're approaching that threshold. In addition to metrics, CMC also identifies any devices that appear in the source data. With the devices, it adds them to the Devices tab, and here you can specify which shift you're going to summarize those devices against. Using the Maintain Shifts button, you can define new shifts. Certain devices are only used during certain periods of the day. For instance, a backup server might only be used in the evening. A SQL server handling an online system might only be used during peak periods. So in this dialog, you can specify how you want the devices summarized and what data from what periods of the day are going to be used for that summary. After you've configured devices and metrics, you can return to the Processing tab and click the All button. This will load all the data, summarize the data by those shifts that we define, and create trends for any metrics that we mark as requiring a trend. At this point, we can schedule the CMC to run overnight. We can use either the Windows scheduler or attach it to an existing process. Now that we've defined our source data and configured our metrics and devices, we need to define a plan. A plan is simply a start date and an end date. CMC uses data from immediately before the start date to calculate a trend, and it projects that trend from start to end. After we've created the plan definition, we need to map devices to it. We map all the devices in our existing system to the plan. Now that we've got our devices mapped, we generate the plan data. To make an adjustment to our plan, we use the Plan Adjustments tab. We select our device, metric, instance and shift, and a chart is presented which shows the blue line, which is the current plan trend. To make an adjustment, we simply scroll down through the data, find the date that the change is going to occur on, and add an adjustment value. In this case, we know at the end of 2014 there's a business event which is going to cause that utilization to go up by 25%. That business event might only last for, let's say, a month, in which case it might then drop by 25%. The CMC system has a number of built-in reports. The first report we'll look at here is the Annual Planning Report. It identifies any device, metric and instance that will breach the defined threshold during the planning period. It shows the end of the plan date, the expected value of that metric at the end of the plan, when it expects that metric to breach its threshold, and a small graphic indicating quarter of the planning period where the metric will be breached. It also has the highest or lowest, depending on the threshold comparator, values it sees throughout the quarters of that planning period.